On to exercise 1, where we calculate a pre-flop score. So as you know, poker hands must be 5 cards, but pre-flop, each player is dealt just 2 cards. So what we want to do here is have a way to assess these 2 cards. How good is, an ace-3? How good is 5-5? How good is king-king? Right? So we need to have this ranking so that we can order these, pre-flop hands of 2 cards that each player gets so that we can know whether it's a good hand or, a bad hand. All right, so what I've done is I've developed a metric that we are going to use in order to give each of these hands a score. So that's what this function is going to do. It's going to take in a hand instance of 2 cards, and it will then follow these rules and assign some numerical value to that hand. So let's see the rules over here. So we're going to find the ranks of the hands. We're going to multiply the max rank by 7, the min rank by 5, and then sum those values together. That'll be our score. If both ranks are the same, that means we have a pair, which is good in poker. We're going to add 60 to the score. If both cards have the same suit, we're going to add 15. So that means it's more likely we'll get a flush when this happens. If the ranks differ by 1, we're going to add 10 to the score. So this helps with straights. If they differ by 2, we'll just add 5 to the score. So that helps with straights as well, but not as much. Okay, so here is the function that we're going to do. We're going to fill out over here. We're going to return a score of a 2-card hand. Right, so it's going to be passed a hand instance, and then it's going to return an integer. So the first thing that we're going to do is just extract the ranks from each card in the hand. So what we're going to do is we're going to get the ranks. So we have hand. So remember, we can use the square brackets. We made our object so that we can use the square brackets. That gets the first card, dot rank, and then hand 1. That's the second card, dot rank. And so that will be a tuple. And then we can actually sort this, just use the same variable, like this. All right, so what we can do at the beginning, what I like to do is just return slowly, just use a return statement. I know this is not correct, but to do that, and so that we can see what's happening, and I created some three hands to check, right? So just ace, ace, 7, 8 of hearts, 7 of hearts, 5 of clubs. So here, I'm just going to run this so I can see the result of my function as I'm building it. So this is a common thing to do. You just have a return statement or a print statement as you're building the function. But this is kind of be a little bit of a longer function, and so it's not always, it's hard to keep track in your mind what's happening. The next thing we're going to do is get the suits, because we'll need it to check whether they're the same suit. So we'll get hand, so the first card dot suit, and the second card dot suit. So that is the suits, and then we go over here and we can see that it says multiply the max rank by 7 and the min rank by 5. So let's go ahead and start our score. So the score will be ranks 0. That's that first one, times 7, plus ranks 1 times, actually this was times 7. So it's sorted. That's what I said. I sorted it, so it's sorted in ascending order. So this is the min rank. That'll be times 5, and that'll be times 7. All right, now what we can do is, let's go to the next. So this does this one, right? That covers that. And it says if the ranks are the same, add 60. And now let's go ahead and just return the score over here. So I have a Hank rank. No, that's supposed to be hand. Okay, it's another good reason to do that. All right, so that's the score so far. They're both 12. This is for the ace ace. We can also do it for hand 2, which will be less, right? Okay, so that's that score, so it looks right. And then what we want to do is, if they're the same suit, then we add 15 to the score. So we can say if suits 0 equals suits 1. So if it's the same suit, then we can add 15 to the score. And then we check this. If ranks, if the difference in the ranks, so if rank 1 minus ranks 0. If this difference is, we can just get the difference, right? So we can say diff, just calculate that. So if this difference is 1, then we're going to add 10 to the score. All right, so right here we can see that 7 and 8, they are suited. That means they're the same suit. So we're going to add 15 to that. And they're 1 away. So we're going to add 10 to that. So that should be 25 more. So 67 plus 25 should be 92. So that looks good. If they differ by, we can also look, let's just look at hand 3 score. So it's 50 right now, 7 and 5. This is not suited. It doesn't differ by 1. But now we can see if the difference is 2, then the score, we're going to add just 5 to it. So I think that's all of them, right? So let's just review this again. So the score, the first part of the score, the main part of the score really is just the min rank times 5, the max rank times 7, add them together. If they're the same suit, we add 15. If the difference is 1 in rank, so helps with a straight, then we add 10. And I forgot, I did not add for the pair, so I completely skipped this one. So I could really say if diff equals 0, that means it's a pair, then the score will be plus 60. So we'll see this score jump up by 60 because that is a pair of aces. All right, great. And let's see, this went up by 5 because it is different. 7, 5 differs by 2. All right, good. So here is the assert statement. We can run this. This just double checks that these scores are all correct. And if there's an error, that means there's something wrong. If there's nothing that happens, then you've got it right. So this is you could have coded this quite a bit differently, right? But so this gets the job done, and that's how we're going to calculate the pre-flop score.